So this lecture today is chapter 2.2, the velocity and momentum, and we know that what the meaning of velocity, guys. Velocity سرعة متجهة. Momentum, we call it الزخم. So the objectives of this lecture today is to understand what the meaning of speed and the difference between the speed and velocity. We studied the speed last time, so today we will study the velocity and we will know what is the difference in between. We will study the motion of two objects relative to each other. And at the end, we will know what is the momentum and how to calculate the momentum. So as we discussed last time, speed describes how fast something is moving. How fast something is moving. It does not need a direction. While the velocity, it describes how fast something is moving plus in which direction. So for the velocity, you need to know the value and direction. The velocity is a vector. Velocity is a vector, متجه. The speed is a scalar quantity. Scalar quantity. So for example, I might say the speed of the car is 20 kilometers per hour. But when I want to tell the velocity, you need to tell that the velocity, its value or its magnitude is 20 kilometers per hour in the direction of the north. Okay, so you need to tell the value and the direction. A question: can the velocity of an object change if the speed is constant? Can the velocity change if the speed is constant? The answer is yes. Yes. If the
Doctor,
object changes, yes.
I'm here. I missed the.
At the end of the lecture, please. At the end of the
Okay.
lecture. So, can the velocity of an object change if the speed is constant? The answer is yes if the object changes its direction. Give me an example. So, if you drive your car in a circle at a constant speed, what happened? Your speed is constant, but your direction is different. So if we take a point like this, point A, look at the speed direction, it will be to the left. Look at point B, for example, the speed direction is downward. Point C, the speed direction is to the right. Point D, the speed direction is upward, and so on. So the speed direction, which you can see it's the purple arrow, V. This is the direction. So the velocity here changes. The velocity changes because the direction of the velocity changes from point A to point B to point C to point D. In a circle, the velocity direction is always tangent to the circle. The velocity is always tangent to the circle. Do you know what the meaning of tangent? You know
No.
what is a tangent? Tangent means مماس. It touches the circle. Like if you have a circle like this one, when you draw a line that touches a circle in one point, we call it tangent. Okay? Understand?
Okay. Thank you.
So at any point, the velocity V is a line or an arrow, as you see it here, tangent to the circle. Okay? Can two objects have the same speed but different velocities? Yes. Give me an example. Let's take this example number one. Two objects are moving horizontally, أفقيا, okay, on the x direction. One of them is moving to the right or in the direction of the positive x, and the other is moving to the left or in the direction of the negative x. So they have the same speed, 1 meter per second, but one is moving to the east, the other moves to the west. So what about the velocity? The velocity of the first one, let's call it A, equals positive 1 meter per second, while the velocity of the second one equals negative 1 meter per second. So for the objects which are moving horizontally, okay, the right is positive, to the left is negative velocity. Also, another example. If the objects are moving vertically in the y direction, if the object moves upward, upward إلى أعلى with the speed 1 meter per second, so its velocity is positive, while the other one, which is moving downward, its velocity is negative. Okay, so also in the vertical direction, upward is positive and downward is negative velocity. For example, if we have two cars here, they have the same speed, 5 meters per second. One of them moves to the right, the other moves to the left. Let's consider this line to be our x-axis. So I would say the velocity of this one is 25. The velocity of the other one equals negative 25 because of the direction. We have two types of velocities: average velocity and instantaneous velocity. We said last time that there was the average speed and the instantaneous speed. What was the average speed, guys? What was the average speed? Do you remember?
Yes.
Yes, Omar?
Average speed when you have a lot of speeds different. We can calculate the
So
speed
how
when
to
you
how to calculate the average speed? Yes, Abdul Ilah?
Delta V.
No?
Well,
Abdul Rahman?
the total distance divided by
Yes.
the total time.
As we studied this one last time. It's total distance over total time. This is the average speed. There is something else called average velocity. What is average velocity? Average velocity is the total displacement over the total time. So what's the difference between distance and displacement? What's the difference between distance and displacement? Yes, Anas?
The distance, the speed with the direction.
Distance or
the distance,
displacement?
with المسافة مع الاتجاهات. الإزاحة من غير الاتجاهات. No direction.
No, you mean the opposite.
The opposite.
So as Muhammad, he wrote here, distance is a scalar quantity. The distance is a scalar quantity, and the distance is the actual length of the track the object is moving on. Okay, the actual length of the track. While the displacement is the shortest length between the beginning and the end, or the start and the end. Okay, and it's a vector. Displacement is a vector. So the average velocity also is a vector, or the velocity in general, it's a vector. And the average velocity, it's a vector, and it has the same direction as the displacement. So let's take this example and try to solve it together. A car moves from point A, moving to the right 10 meter, and please prepare a calculator. Please prepare a calculator. 10 meter to the right, then maybe 10 meter to the upward, then another 10 meter to the right, then let's say 10 meter upward, then let's say 30 meter backward until the car reaches point B. So what is the total distance here? Total distance. What's the total distance? 70, that's right, 70 meter. Excellent. So what is the average speed, V average? Let's say this car needed, let's say this car needed 10 seconds to go from A to B. So the average speed equals the total distance, which is 70 meter, divided by the time, which is 10 seconds. So the result is 7 meter per second. So this is the average speed. Does it need a direction? No, it does not. Speed does not need a direction. Now let's go to the velocity. To calculate the average velocity, you need to calculate the displacement. So where is the displacement here? Displacement is the shortest distance between the beginning and the end, which is this green arrow. And I make it arrow because it's a vector. Displacement is a vector. Let's call it R. Let's call it R. How to get R? To get R, you need to calculate the value of X and Y. This is X, and the vertical is Y. What's the value of X, guys? X equals what? 10. That's right. 10 meter. And Y is 20. That's right. So by Pythagoras rule, we calculate the R. If you have a calculator, do it 10 square plus 20 square, which is almost 20 what? If you have a calculator, do it 25, 22. So almost 22.4 meter. 22.4 meter, approximately. So the average velocity, V average, I will make it big V like this one. The average velocity equals total displacement, which is 22.4 meter, divided by the total time, which is 10 seconds. So the result will be 2.24 meter per second. So this is the average velocity. Is it enough to tell that the average velocity is 2.24? No, it's not. It's not. What do we need else? We need a direction. We need a direction. What is the direction? Somebody might say roughly it's northwest, as Omar says here. Roughly it's northwest. But from the point of view of engineering, that's not enough. It's not enough to tell that it's northwest. But usually we need an angle. We need an angle. So you need to look and find an angle. Somebody might say, I will find this angle phi. Somebody else might say, I will find this angle theta, or this angle theta also, they are equal. Okay? So it's up to you. You can find the angle phi or angle theta. It's up to you. Okay? Which angle do you prefer? Just give me a choice. It's up to you. The first one? The second one? Let's take theta. Let's take theta. So I can say tan theta equals the opposite, which is 20, divided by the adjacent, which is 10. المقابل على المجاور. Okay, so tan theta is the opposite over the adjacent 2. And I can make shift 10, so theta equals what? 63.4 degrees. So now it's exactly the direction. 63.4, you can say 63.4 with the horizontal or northwest. It's up to you. Okay, if you want it exactly northwest. So now I know the difference between the average speed and average velocity. Average speed was 7 meter per second. Average velocity is 2.24 meter per second, and its direction is 63.4 northwest. Okay, guys? You have a question here? You understand it?
How it's equal 63?
How is it what? 63? Tan theta is y over x, 2 over 1 or 20 over 10. Then you make shift plus tan of 2 on the calculator. It gives you 63.4. Okay? Got it? So this is on the calculator. Shift plus tan.
We're allowed to use the calculator in the
You
exam.
you must use a calculator in the physics exam. You must use a calculator in the physics exam. Okay? It's different from the math and the other curriculums. Okay.
Doctor, how can the exterior angle?
Which one?
The one like near to the A.
This one?
Yes. No, the other one, the outer one.
You mean this one, or what?
No, the one from the outside, the exterior.
This one?
Yeah. No. The one
This one? Which angle do you want?
that
You
has
said
the
at A.
yeah, the straight line, and between the straight line and the R line.
Between the red line or the green line? Between the red line and the R?
Yes.
This line, you mean? This line?
Yes, and the
And
green
this
line.
R? And this
Yes.
R? The angle is theta. Which, do you need another angle? Like this one, you mean? Hmm? I don't get
No.
it. I don't get it. Like we can get any angle. We can get any angle. We found theta. Okay, 63.
Yes.
So the other angle, phi, for example, it's 90 minus theta. Okay,
Yes.
the other one here is 90 degree. The other one here equals 180 minus theta. You can get any angle. This one equals theta. They are vertical
Yes.
angles. Okay, so you can find any angle if you want. It's up to you. Okay. So the other part here is the instantaneous velocity. Instantaneous velocity. We said the instantaneous speed is for the instantaneous speed, you need to look at the speedometer. Okay. Also for the instantaneous velocity, you need to look at the speedometer. But also you need a compass. Okay. Busla. So look at the speedometer to tell the value of the velocity. The value of the velocity here is 110. Okay. And look at the compass to tell the direction. Let's say, for example, it's northeast. Okay. So the instantaneous velocity needs a value and direction, the instant value and the instant direction. Relative velocity. Relative velocity. When an object A, relative velocity means السرعة النسبية، السرعة المتجهة النسبية. When an object A is being observed by another object B, its velocity will be described as the velocity of A relative to B. Like, for example, you are driving your car. Okay, so you are here driving your car. Okay, enjoying everything at, let's say, 100 kilometer per hour. And on the other lane, the lane beside you, there is another car. Okay, so it also has the same speed, 100 kilometer per hour. Then I will ask you, for example, I will say, Ahmed, for example, can you describe the speed of other car relative to yourself? So Ahmed will look at the other car. What will you say? Relative to yourself. Relative to yourself. That's right, guys. Relative to yourself, it has zero speed. It's zero. Okay, it's not moving. Okay, so this is a kind of you imagine that the other car is not moving because you are describing the motion of the other car relative to yourself or relative to your car. But the real situation is different. The real situation is both cars are moving at 100 kilometer per hour. So you will say it's zero. What if the speed increases and becomes 110 kilometer per hour, and then I will ask you again, Ahmed, please describe the other car. So you will say what? You will say 10. That's right. That's right. So in which direction? So you will think that this car is moving forward at 10 kilometers per hour. That's what you think. Or that's what you imagine. That's what you can see relative to yourself. So what if the speed of this car becomes 90 kilometers per hour? And I will ask you again, describe the motion of the other car. You will say what? Your speed is 100 and the other speed is 90.
He can't see
So
it.
you will say, I feel like the other car is moving backward, right? It looks like it's moving backward relative to yourself at a speed 10. So we can say its velocity is negative 10. We can say its velocity is negative 10 kilometer per hour because you will feel that it's moving backward at 10 kilometer per hour. So what you describe is called the relative velocity. You, when you are looking, we call yourself the observer. Observer. What does it mean, observer, guys? The one who is looking and the one who observes. Okay? المراقب. تمام. Good. So the one who is looking, we call him the observer. This is the one who's looking at the other one, which is the object. The other one, we call it object or target sometimes. Okay? Object. Let's say the object is A and the observer is B. So I will ask you, what is the velocity of the object relative to the observer? The velocity of object relative to observer, or the velocity of A relative to B, or the velocity of A as measured by B. So we write it down, V, A, B. A is the object, B is the observer. Equals what? Equals VA minus VB. This is the equation for relative velocity. VAB, or VA relative to B, equals VA minus VB. The velocity of the object minus the velocity of the observer. Let's take an example. Two cars, one is moving to the right at a speed 25, the other moves to the left at a speed 25 meters per second. Find VAB. VAB. What does it mean, VAB? A is the object and B is the observer. Observer, so someone is riding here and is looking to at the car A. So it's VA minus VB. And take care that we are dealing with velocities, not speeds. Velocity, not a speed. So we need direction. The first velocity is 25, and the other one is negative 25. So VA equals negative 25 minus VB is 25, so the result is negative 50. What does it mean, negative 50? What does it mean? Can you interpret this answer? 50 to the left, that's right. It's 50 to the west or the left. Excellent. So it means when B is the observer and he is looking at A, he will feel that A is moving to the left at 50 meters per second. That's his feeling. Okay, so that's called relative velocity of A relative to B. Let's take the other case. VBA, find VBA. So in this case, A is the observer. A is the observer. So we will reverse it. The observer will be A and he's looking at B. So it's VB minus VA. VB is 25 minus and VA is negative 25. So the result will be 50 meters per second. What does it mean here, 50? It's 50 to the right. So when A is looking at B, he will feel like B is moving to the right at 50 meters per second. That's his feeling. This is what we call relative velocity. Let's try to solve this problem and we will understand it more. A hurricane moves towards a house at a speed 30 kilometers per hour west. We have a hurricane hurricane. Let's say a hurricane and a house. Let's say this is a house. And a hurricane. You know what the meaning of hurricane, guys? Hmm? You know what the meaning of hurricane? إعصار. Okay. But usually the hurricanes come from oceans. This is a hurricane. Okay. It moves to the west at 30 kilometer per hour. I will call the hurricane H. I will call it H. A car moves away from the house. There is a car that's moving away from the house at a speed 100 kilometer per hour west. So the car is moving away to the west. This is a car. Somebody is here driving, trying to escape from the hurricane at a speed 100 kilometer per hour. I will call it C. So what is the question? What is the velocity? What is the velocity of the hurricane relative to the car? Hurricane relative to the car. The object relative to the observer. So you need to find V of hurricane relative to the car, which is VH minus VC. Okay. Before you answer this question, we are dealing with velocities, not speeds. So I will imagine that this is X direction. So the velocity of the hurricane equals negative because it's to the west. And the velocity of the car also negative because it's to the west. That's what he said, west and west here. Okay. So VH minus VC is negative 30 minus negative 100. It gives you directly 20 kilometer per hour. The result is positive. And positive here means it's to the right. It's to the right. So this person, this guy, when he looks at the hurricane, he will feel like what? He will feel like the hurricane is moving, and he imagines that the hurricane is moving to the right at 70 kilometers per hour. Okay, that's what he imagined. Or we can say it in other words, he feels like the hurricane is moving away from him. It's moving away from him. So he is moving to the west, moving away from him, meaning that it's moving to the east. Okay? At a speed 70 kilometers per hour. So the right answer will be number one.
Doctor,
Yes.
have a question. Why VH is minus, not
Because
positive?
he said here west. And I used the positive sense to be out my X direction. This is my positive sense, which is generally right. I said positive to the right, negative to the left. Okay.
Okay,
That's
you.
what I did. You're welcome. Do you understand this problem? So let me try to change it a little bit. Let me try to change it a little bit. What if the speed of the car is 30 kilometers per hour? What will happen? So the speed of the car is the same like the speed of the hurricane. Huh? So the relative velocity will be 0. That's right. So the driver of the car, when he looks at the hurricane, he feels like the hurricane does not move. Of course, both of them are moving, but the distance in between will stay the same. The distance in between will stay the same because they have the same speed. So when he looks, like every minute he looks at the hurricane, he will find it at the same distance, so he will feel that it's not moving. Okay. What if he is driving at, let's say, 10 kilometers per hour only? 10 kilometers per hour. He will feel what? Yes, 20 kilometers west. So if he's driving at 10, so VHC equals VH minus VC. So negative 30 minus negative 10 gives you negative 20. What does it mean? When he looks at the hurricane, he will feel that the hurricane is moving slowly toward him, okay, at a speed 20 kilometer per hour. So he will feel that the hurricane approaches him, تقترب منه, okay. That's the three cases we need to discuss. Do you have a question? You have a question, guys? Did you understand it? Okay, let's move to another problem.
Yes,
A
doctor.
bus. Yes,
Can
go
you
ahead.
back to the
Go ahead.
if the cars move to the right
Okay, if the car is moving to the right, which you
and the
shouldn't do, by the
hurricane
way. If the car is moving to the right, we should tell you goodbye. Hmm? Huh. This is the car moving to the right. With what speed? Which speed do you want? Hmm. The
100
same, 100 for
kilometer
example?
per
100.
hour.
Okay. Okay. So in this case, it's positive 100 because it's to the right. So VH is negative 30 minus 100. So the result is negative 130 kilometer per hour. So when this guy looks at the hurricane, he will feel that the hurricane is moving towards him at a speed 130 kilometer per hour. So it's like he says hello. He's meeting the hurricane very happily. Okay, understand it?
Yes, understand. Thank you.
Okay. So the other problem, a bus is moving at 80 kilometer per hour in front of a car. This car is moving at 100 kilometer per hour. So we have like bus is moving in front of a car. The bus has a speed 80 kilometer per hour. The car has a speed 100 kilometer per hour. If the distance between the bus and the car is 5 kilometers, the distance in between is 5 kilometers. How long will it take for the car to reach to the bus? How long will it take for the car to reach to the bus? Of course, the car gradually will move until it reaches to the bus because it has higher speed. It has higher speed. Like let's say somebody is staying here in the bus, but he is looking to the car. He will see what? Huh? If the guy in the bus is looking at the car, he will imagine huh, that the car is approaching him at a speed which is difference between the two speeds, right? That's normal. But how can we do it analytically? This guy is the observer. Let's call it bus and the other one car. So we need to find the velocity of the car relative to the bus, which is v car minus v bus. Both velocities are positive. They are to the right. So v car is 100, v bus is 80. So the difference is 20 kilometer per hour. And the difference is positive. That means this guy in the bus, he's feeling that the car approaches him at 20 kilometer per hour. Okay, 20 kilometer per hour. The distance in between was 5 kilometer. The distance, excuse me, distance 5 kilometer. I need to find the time. So I know the approaching speed and I know the distance. I need the time. Okay, so I can say the speed equals distance over time. Okay, it's just a straight line motion. Or you can say the time equals distance over speed. So the time is distance, which is 5 kilometer, divided by the speed, which is 20 kilometer per hour. The result is 1 over 4 kilometer, sorry, 1 over 4 hour. Kilometer goes with the kilometer. So 1 over 4 hour means quarter of the hour, quarter of an hour. Okay, quarter of an hour is what? 60 minutes over 4 gives you 15 minutes. Because 1 hour is 60 minutes. So 15 minutes will be the first one. Okay, guys? So this is the answer. You can solve this problem with your friends. If you cannot, you can come during the office hours and we can discuss it. Okay? The momentum. Momentum. What is the momentum and why do we need momentum? Let's look at this picture. We have truck and we have a ball. Both of them will move at the same speed, which is, let's say, 5 meters per second. Okay. And there are two nice guys here. They are waiting for something. I don't know what is it. What will happen when the truck reaches to the guy here and when the ball reaches to the other guy? What do you think will happen if they are moving at the same speed? What do you think, guys? Huh? Can you tell me what might happen? So this guy can stop the ball. He can stop the ball by his leg or his foot, for example. Okay, he can stop the ball. But while the other guy, the car might crash him or might throw him away. That's the truck. Okay. So what's the difference here? The difference is what we call the momentum P. The momentum. The momentum is a quantity, it's a vector actually, equals the mass times velocity. The mass times velocity. It tells you how powerful a moving object is. Is it a strong object or not? Can it push you or it cannot? Can you stop it or you cannot? Okay, so this phenomena is the momentum, or this physical quantity is the momentum, which is mass times velocity. The difference between the ball and the truck is the mass. The truck has big mass while the ball has small mass. So it will be easy for the boy to stop the ball, but it will be very hard for the other boy to stop the truck. Okay, which we call it zakham. Yes, zakham. That's right. How to increase the momentum? By increasing the mass or by increasing the velocity. Like, let's take this ball and let's make another story for the ball. I will put the ball in a cannon. Do you know what is a cannon? Do you know what is the guys? Yes. So then I will fire the cannon. I will fire the cannon. Okay, the ball will move out of the cannon at a very high speed. Let's say 100 meters per second. In this case, can you stop it? Okay, or maybe 200, or maybe sometimes it depends on the cannon itself. Okay, if it moves at 100 meters per second, can you stop it? You cannot stop it. I did not change the mass, but I increased the velocity. So if you increase the mass, you increase the momentum, and the object becomes very powerful. If you increase the speed also, you increase the momentum, and the object also becomes powerful. You understand? So here we have two factors, the mass and the velocity. The momentum, as I said, is a vector. Its direction is the same direction as the velocity. So the momentum and the velocity, they have the same direction. Sometimes they put this dash above the symbol to tell you that it's a vector. Okay. The unit of mass is kilogram. The unit of velocity is meter per second. So the unit of momentum is kilogram meter per second. Let's try to solve this problem. When a car moves at speed 25 meter per second, its momentum is 50,000 kilogram meter per second. What is the mass of the car? What is the mass of the car? I will do what? Momentum equals mass times velocity. The momentum here is 50,000. The mass is not known, while the velocity should be, the value of the velocity is 25. So the mass simply is 50,000 divided by 25. It's 2,000 kilogram. Understand it? Very easy, very easy. So the
Doctor,
right answer is number one.
I
Yes,
have a question.
yes.
Why we use the masses? Don't use the white or
The weight.
wait.
Yes, the weight depends. The weight depends on the gravity, as we will discuss it soon, inshallah. The weight depends on the gravity. Okay, but the mass is how much matter inside the object. How much matter inside the object, and this is what affects the power of the object, or the strength of the object. How many mass inside this object, or how much matter inside this object, which is the mass. So the weight is not part of our work here. The weight depends on the gravity.
Yes, thank you. I understand that. Thank
Okay.
you.
If we have, I will need like 3 minutes. If we have a bullet, you know what the meaning of bullet, guys? Rasasa. And if I have a ball, the mass of the bullet equals 10 grams. 10 grams. And the mass of the ball equals 0.5 kilogram. If you fire the ball and if you shoot the ball, if the speed of the ball equals, let's say, 10 meter per second, 10 meter per second, find the speed of the bullet, find the speed of the bullet if they have the same momentum. If the ball and the bullet have the same momentum, find the speed of the bullet.
نعوض.
What can you do? I will say the momentum of the ball equals the momentum of the bullet. So the mass times velocity of the ball equals mass times velocity of the bullet. I know what? I know the mass of the ball is half kilogram. The velocity of the ball, I know the value is 10. The mass of the bullet is what? What's the mass of the bullet? It's 10 grams. You need to convert it into kilogram by dividing it over 1,000. So it will be 0.01 kilogram. Time is v bullet. So the speed of the bullet, easily, it's 0.5 times 10 divided by 0.01. Gives you what? 500 meter per second. So the speed of the ball, 500 meter per second. So if the ball moves at 500 meter per second, they will have the same momentum. They will have the same momentum. What is the value of this momentum? The value of this momentum is 0.5 times 10. That's 5. 5. The momentum of each one equal 5 kilogram meter per second. I want to calculate the momentum. You understand it? So that was everything today. I hope you understand now what the meaning of velocity and what the meaning of momentum, what's the difference between the speed and the velocity, how to calculate the average velocity, and how to calculate the relative velocity. Okay, thank you so much.